In this tutorial, we will be discussing valence electrons as dots. Alright, so we're going to start doing something called a Lewis dot structure. The Lewis theory is named after G.N. Lewis, an American chemist who developed it. It's a way to draw molecules very easily. We represent electrons as the dots and draw what we call the dot structures, or the Lewis structures, to represent molecules. These structures have tremendous predictive power because if we know how the model looks, then we know how it's going to act. Lewis theory can determine whether a particular set of atoms will form a stable molecule or what the molecule might look like. Although modern chemists also use more advanced bonding theories to better predict molecular properties, Lewis theory remains the simplest method for making quick, everyday predictions about molecules. So in the Lewis theory, the valence electrons of main group elements are represented by dots surrounding the symbol of the element. And this is what we refer to as the Lewis structure or the dot structure. So for valence electrons, we talked about valence electrons with electron configurations. The row that it's in, the group that it's in, is how many dots it should have because that's how many valence electrons it has. For instance, the first row will have 1 dot, while the second row has 2. Row beginning with boron is 3, carbon is 4, nitrogen is 5, oxygen is 6, fluorine is 7, the halogens, and the inert gases are 8. With the exception of helium, but that's only because there's only 2 electrons here, so therefore it can only have 2 dots. But whatever row it's in is how many valence electrons it's going to have. To give you an example, here's oxygen. When we look at oxygen on the periodic table, it's right here. It's in row 6. The atomic number of oxygen is 8. So if we look at the electron configuration, 1s2, 2s2, 2p4, that equals 8 electrons. Well, if we take the outermost electrons, which are the valence electrons, they begin with 2's. So 2s2, 2p4. So 2 and 4 mean that we have 6 valence electrons here. So its Lewis structure will have 6 dots around it. 1, 2, 3, 4, 5, 6. Each dot represents a valence electron. The dots are placed around the element symbol with a maximum of 2 dots per side. Although the exact location of the dots isn't critical, we do fill in the dots alone first and then we pair them up. So if we go back to the oxygen again, you'll notice here's the symbol for oxygen. It had 6 dots, so 1, 2, 3, 4. So there's 4 there, 5, 6. So you go around 4 times and then you go and pair them up. It is important to follow this convention when doing the homework. So here are all the dots from period 2 elements. Notice that once we get to 4 with carbon, you start pairing them up until everything is full. Neon is an inert gas. It's a noble gas. Notice that there's a maximum of 2 on each side. So when looking at that, there's our 8. That's called the octet. Lewis structures allow us to easily see the number of valence electrons in an atom. Atoms with 8 valence electrons, which are particularly stable, are easily identified because they have 8 dots. An octet. It's called the octet rule. Alright, so here's the lithium. It's in row 1. It only has 1 dot. Beryllium is in row 2, so it has 2 dots. Boron is in row 3, so it has 3 dots. Carbon is row 4. Nitrogen is 5. Oxygen is 6. fluorine is 7, and then neon is 8. So when you're counting from left to right, if you look at the representative elements, which are the tall ones, that's how many dots you should have around it. So we can write the structure of phosphorus. Phosphorus is right here. 1, 2, 3, 4, 5. It's in the 5th row, group 5A, on the periodic table. That means it has 5 valence electrons. So we write the letter P for phosphorus, and then we put 5 dots around it. 1, 2, 3, 4, and then we have another one. Now where you put that 5th dot is completely irrelevant. Notice on the left-hand side, they put them both on the right side. Here I put them both on the top. Both of these are correct. As long as you have 3 singles and 1 double, you're fine. Alright, so let's try some more. Let's try carbon. Carbon is here. 1, 2, 3, 4. We start by putting the symbol for carbon, and then we're going to follow with 4 dots. 1, 2, 3, 4. That's all there is to it. Chlorine is here. 1, 2, 3, 4, 5, 6, 7. That means we have 7 dots around it. So Cl, 1, 2, 3, 4, 5, 6, 7. So you'll have 3 pairs and 1 single. And then sulfur is right here. 1, 2, 3, 4, 5, 6. We have the letter S for sulfur, and we want 6 dots. 1, 2, 3, 4, 5, 6. 2 singles and 2 pairs. Helium is an exception. Its electron configuration of Lewis structure is this. The electrons are already paired up. The Lewis structure of helium contains 2 paired dots, or a duet. For helium, a duet represents a stable electron configuration because that's all it has. The s orbitals only have 1 orbital. So therefore, unlike the S and P, you'd only have 1 side of it. And that's how you represent the valence electrons as dots.